Build AI ML-powered advanced analytical solutions with Incorta and Sparkflows. Incorta is a robust open data delivery platform used for acquiring, processing, analyzing and presenting decision-ready data. Sparkflows complements it with a powerful self-serve no-code, low-code data science orchestration platform. It seamlessly integrates with Incorta for building complete end-to-end data science solutions. Users build workflows in Sparkflows for data ingestion, preparation, and ML model building. The workflow reads data from Incorta materialized views. Once the workflow is built, the job is submitted to Incorta via Incorta API using the Chidori API. The job writes results to the Incorta object store. The job also writes the ML models to Incorta object store. Workflow summary, metrics, etc. will post back to Sparkflows. Prediction results can be merged with other datasets, and enriched insights are displayed on the Incorta dashboard. Sparkflows pushes the model summary and metrics to Incorta ML flow registry. And use the kubeflow for model serve. Users can also import external model into Sparkflows. The foundational framework thus built combines the core strengths of the two and presents a unified data analytics platform to build and port advanced AI ML-powered analytical solutions onto it. Transaction data is shared in the business schema in the prescribed data model. Data is ingested and data preparatory tasks are performed encompassing EDA. Data profiling and data transformation. Data quality checks are performed using various inbuilt nodes such as check for null, drop null rows, imputing missing values, and so on. Feature engineering is performed to compute features to be used for model training. Model is trained to solve the ML problems such as prediction, segmentation, time series forecasting. Prediction values are derived using model trained and feature data. Model is served using MLOps steps. Analytical apps facilitate users with an UI to perform complex ML processing on click of a button. Model prediction and model metrics data is written on Incorta data layer. Charts are generated on dashboard to visualize trends for descriptive and predictive analysis. Users leverages these dashboards to make business decisions. Let's uncover the full potential of this integrated platform by exploring the customer lifetime value solution through a demo. CLTV stands for Customer Lifetime Value. It is a metric that represents the total amount of revenue a business can expect to earn from a customer over the entire duration of their relationship. The CLTV solution helps business to accurately forecast CLTV value for each customer. It benefits business in strategic decision-making related to customer acquisition, customer retention, marketing efforts. Let's dive deep into the CLTV advanced analytics solutions built in collaboration between Incorta and Sparkflows. There is a business schema created within Incorta for the CLTV use case. Sales table has been created within Incorta exposing the transaction data. It contains the list of columns as per the prescribed input data model. Input dataset contains details such as invoice number, invoice date, customer ID, stock code, quantity, and so on. Sparkflows leverages the read Incorta or in-build nodes to ingest the data from Incorta data objects. After reading the data, it undergoes various transformations using inbuilt nodes such as typecasting, date-to-string conversion, SQL node to execute custom SQL queries, process an expression, concatenate columns, and so on. After completion of all transformations, curated data for CLTV is saved in Parquet format using Save Parquet node at the prescribed GCS location. Curated and transformed CLTV transaction data saved in the earlier stage is now being used for CLTV model training and predictions. Process data is read using the Read Parquet node. It reads data from the path on GCS location on Incorta where process data resides. Over here, process data file contains feature data that has been created by the intermediate steps. Multiple features are computed from the input dataset to train machine learning models such as frequency of purchases, recency of purchases, purchase history duration, average days between purchases, average products per invoice, total invoice amount over customer's lifetime, average invoice amount per invoice, purchase count of unique products. Data undergoes various machine learning steps such as model building, model saving, model prediction, and so on. CLTV value for each customer is predicted. Model evaluation metrics are also computed using the inbuilt node. CLTV prediction results are saved using the Save Parquet node. It is saved on the GCS location on Incorta. At Incorta end, a table is created on top of the saved data. This table holds the prediction results. It contains predicted CLTV values for each customer. Incorta table has been created using the saved predicted dataset on Incorta. Saved data on the Incorta tables is further used to build dashboards on Incorta. Multiple dashboards can be created on Incorta. Processed dataset can be combined with other datasets such as customer order details, account receivable, aging records to represent data in various perspectives. Incorta provides a holistic view of the data, spanning across multiple tables and schemas. Using Incorta, it is easier to drill down from high level to details in the same dashboard. To further enhance the decision-making process, prediction results from Sparkflows can be incorporated. Customers are grouped together in various segments to prioritize them based on common buying pattern. Incorta tables can also be used to create descriptive analysis dashboards on Incorta, such as trends on monthly total sales, monthly transaction count, monthly quantity sold, and so on. So far, we've explored the seamless integration between Incorta and Sparkflows using the CLTV use case. Here's a glimpse of other AI-powered apps available on Sparkflows that can be leveraged to build advanced analytics solutions on Incorta.